Factorising into brackets, double brackets with adamonlinetutoring. Here are the beginner questions, some of the easiest types of questions that you're likely to find on this topic. A quadratic expression is an expression where the highest power of the variable is 2. They have the form of ax squared plus bx plus c, where a, b and c are constants that do not equal 0. So with this example, we have 1z squared, meaning that a would be 1. We have 8 lots of z, meaning that b would be 8. And we have a constant of 12 added on to the end, meaning that c would be equal to 12. You can factorise some quadratics into double brackets. The way that we'll get z squared is by having z in one of the brackets multiplied by z in the other bracket when expanding. The way you'll get plus 12 is as a result of timesing these two numbers together, and the way you'll get positive 8 is as a result of adding these two numbers together. A list of numbers that add to give you positive 8 would be endless. Therefore, it would make more sense to start with numbers that multiply to give you positive 12, since factors are limited. I could have positive 1, positive 12, positive 2 and positive 6, positive 3 and positive 4. Now to end up with a positive 12, I could also have negative 1 and negative 12, which means I could also have negative lots of the other factors too. But I'm looking for the factors that add together to give me positive 8. There's no way that adding two negative numbers is going to give you a positive. Therefore, I can use this as a shortcut to leave out the negative factors. Adding these together, I'm looking for the ones that give me positive 8. The first would be positive 13, the second, positive 8, and the last, positive 7. Because it's these two factors, which multiply to give me 12 and add to give me 8, these are the two numbers that would go inside the bracket, z plus 2 and z plus 6. The good thing about algebraic topics is you're usually able to check your answers. We could expand these two brackets together to check to see whether they give us the original expression. On to the next question. I'm looking for numbers that multiply to give me 4, plus 1, plus 4, plus 2 and plus 2, negative 1, negative 4, negative 2 and negative 2. Now I'm looking for the ones that add to give me negative 5. The first would be positive 5, then positive 4, negative 5, and then negative 4. So these are the two factors that I'm looking for. Therefore the answer would be x minus 1, bracket x minus 4. For the last question, I'm looking for numbers that multiply to give me negative 18. To end up with a negative, one of your factors must be negative and the other must be positive. This increases the amount of combinations we could have, as not only could I have negative 1 and plus 18, but I could also have positive 1 and negative 18 also, negative 2, positive 9, positive 2, negative 9, negative 3, positive 6, positive 3, and negative 6. Adding these, the first would be positive 17, then negative 17, positive 7, negative 7, positive 3, and then negative 3. And the ones I was looking for were the ones that gave me positive 3. So the final answer would be x minus 3, bracket x plus 6. On to the intermediate questions. With an increase in difficulty, when factorising quadratics where a is larger than 1, there are a few extra steps that you need to do in order to factorise. The only way we'll be able to get 2y squared by expanding these brackets is for one of the brackets to contain 2y and the other bracket to contain y. Now we are still looking for factors that multiply to give us positive 1. So in this case, the only combinations are positive 1 and positive 1 and negative 1 and negative 1. Notice how currently neither of these add to give you the positive 3 that we were looking for. That's because one of the numbers has been multiplied by 2y, meaning we need to find which one of these has been multiplied by 2 and added to the other one to give us the 3 that we have here instead. It's definitely not going to involve the negative factors since they need to add to give me a positive 3. So just focusing on positive 1 and positive 1, because they're both the same, it doesn't matter which one of these we multiply by 2. Now we can see that they add to give us the 3 that we're looking for. and you just need to make sure that the one you multiplied by 2 goes in the opposite bracket to the one that contains 2y. So plus 1 over this side, but since they're both the same, it doesn't matter which way round we put these. Now this involves a lot of trial and error and room for mistakes. This one wasn't too difficult to do because all of the numbers in the quadratic were relatively low. They were prime numbers and produced not many different combinations. But with different quadratics, such as the second and third one, where you have numbers with many factors, the number of combinations increase, making trial and improvement a lot more difficult to find the correct answer. Instead, we can use something which works every single time, and it's called the AC method. The reason it's called the AC method is because you start by multiplying A of the quadratic by C of the quadratic. In this case, that gives us positive 12. Now I list the factors of positive 12. I could have plus 1 and plus 12, plus 2 and plus 3, plus 2 and plus 6, plus 3 and plus 4. I could also have negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. I'm looking for the ones that add together to give me the negative 13 in the middle. Adding all of these together, I can see that it's negative 1 and negative 12. Instead of these numbers being the ones that go inside the bracket, what we can do is rewrite the original quadratic, but we split the term negative 13b into negative 1b and negative 12b. It doesn't matter which one of these you put first or second, but you split it in half and you factorize each side into single brackets. So on the left hand side, the highest common factor between both terms just leaves me with b outside, and inside the bracket would be 2b take away 1. Whatever you get in this bracket is always the same as the other bracket, and this will make it easier to factorize, since I can see to get from 2b take away 1 to negative 12b plus 6, I would need to have negative 6 outside the bracket. Your final answer will be written as double brackets, and how you decide what goes into the brackets is by looking at what's in each of the individual ones above. So that would be one of them, 2b minus 1, and the other bracket is made up of the factors that are outside of the single brackets. In this case, it was b take away 6. If you are able to factorize these using trial and improvement quite quickly, then that's great, but this is a method which will work every single time. I'm going to use the AC method for the last question. 6 multiplied by positive 6 is positive 36. Listing all of the factors that could give me positive 36. These are all of the positive ones, but I could also have negative versions. Adding all of these together and looking for the ones that add to give me negative 13. Are negative 4 and negative 9. Rewrite the quadratic, splitting negative 13t into minus 40 minus 9t. Factorising the left hand side into a single bracket would give me 2t on the outside and 3t minus 2 on the inside. I know that this bracket will be the same as this bracket, making it easier to find the factor on the outside, which would be negative 3. Finally, my factorised double brackets would be made up of 3t take away 2, and then the factors outside the single brackets, which are 2t minus 3. On to the advanced question, one of the trickiest questions that I've managed to find on this topic. To find the ratio of x to y, I'll first have to find out what x and y are. It looks like I'll be able to do that by solving the equation given to me at the top. To be able to solve, we'll need to make this equal to 0. So taking 7xy from both sides and 20y squared from both sides will give me 6x squared minus 7xy minus 20y squared is equal to 0. Using the AC method and multiplying 6 by negative 20, that gives me negative 120. Now there's lots of different factors for 120, and I have double the amount of combinations because it's negative. So I'm just going to start by leaving out the signs and listing what the actual factors are. 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 8 and 15, 10 and 12. Now imagining that one of these was positive or one was negative, there's no way that I'm going to be able to add or subtract 1 and 120 to give me the negative 7 that I'm looking for. That would be the same as 2 and 60, 3 and 40. All of these numbers are too far away from each other to be able to get negative 7 as a result, until I get down to 8 and 15, where there's a difference of 7 between them. So now I just need to think about which one of these is negative to give me negative 7 overall when adding. And that would be if I had positive 8 take away 15, which would give me negative 7. So I'll rewrite the quadratic and I'll split negative 7xy into plus 8xy, take away 15xy, minus 20y squared is equal to 0. Split the quadratic in half and factorize each side into single brackets. The left hand side would have 2x on the outside and 3x plus 4y on the inside. These brackets will be the same, so 3x plus 4y here, meaning to factorize the left hand side I would need to have negative 5y on the outside. Now writing these as double brackets, one of the brackets would be 3x plus 4y and the other bracket would be made up of 2x minus 5y. To multiply one bracket by another bracket and end up with 0, one of your brackets must have been equal to 0. So if 3x plus 4y is equal to 0, that would mean that 3x was equal to negative 4y. And if 2x minus 5y was equal to 0, that would mean that 2x must be equal to 5y. That would mean that the ratio of x to y for this first solution would be 3 to negative 4. Notice how in the question at the top it told us x had to be greater than 0 and y had to be greater than 0. Therefore, the correct solution needs to be where both of these were larger than 0 and both positive, which is this one on the right hand side. For every 2 lots of x, you have 5 lots of y. Therefore, the ratio of x to y would be 2 to 5. Before you go, take a look at this solution which I've provided for a question. It appears as though I've made some mistakes. Pause the video, see if you can find them, and either tell me what they are or write some corrections in the comments below. Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.